Hello and welcome to Quantum IAS. In this video, we are going to discuss the question that was posted on 4th of the December, right? So let us analyze this question. So this question is also from previous year questions, and it is again from the mechanics section, and the topic that we are chosen for this question is center of mass. Now, this is a very direct kind of question. Okay, and uh, in past few years we are not getting these types of questions, but anytime these types of questions may be asked, or in any part of the question it can be asked in merge form, right? They can give you this question and along with a numerical. So answering this question is very important. Now, as you can see, this is a very direct question. What do you mean by the center of mass of a system of particles, right? So we have to discuss center of mass regarding the system of a particles. Okay, so okay, also we have to derive the expression for the instantaneous position vector and velocity of the center of mass of such system of particles. Now this is a very easy question. If you ask any person who is reading in class 11th, or you can say some in ninth class also, they can easily answer you this question. But how to write this question is the true sense. So first of all, you have to define in the introduction section, what do you mean by the system of particles? So system of particles are the interacting, or you can use this one, wait, what you can say are the particles, or you can say the group of particles interacting with each other and are under our observation, right? So you first need to define what do you mean by the system of particles. Then you should define what do you mean by the center of mass. So I'm using the abbreviation, you should use the full one, right? So center of mass of system of particle, do not use these abbreviation, use the full length word. System of particle is defined as a hypothetical, or you can say imaginary point at which all of the masses are concentrated there. So what does it mean? So all of the masses are concentrated there. It simply means I'm going to specify in Newtonian mechanics. Mass is basically related to, or basically it's the inertia of the body, right? Related, or you can say mass is the what? Inertia of the body and translational motion of the body. Body can be rigid, non-rigid, continuous, or discrete. Any type of body is translational motion. What I can say, translational motion of the body can be viewed as the translation motion of center of mass. So try to understand these things. Okay, what I'm going to give you, whatever the system is, whatever the system, it may be rigid, it may be non-rigid, it may be discrete, it may be continuous. So its complete motion is what? Motion of a single point, that is center of mass, right? So instead of studying the translational motion of the center or system of particles, you can study the center of mass, right? So you can give this. Also, we can write, so that was in the introduction part. So you should write in a very small font, right? And you should write all of these things. So let us consider a discrete system of n particles. Okay, so we are considering discrete system of n particles. So we have one here, we have two here, we have three here, and up to n here. So what I'm going to give here, so for any ith particle, I can write Fi internal plus Fi external is equals to rate of change of the ith particle upon t. Just try to understand these things. What is this? This force internal is what? Is due to the forces due to the particles inside the system. What you can say, let's suppose there is, here is mass m1, here is mass m2, right? And if the whole system we are pulling it like here, so this one is what? The external force. But there will be a gravitational attraction between m1 and m2, so it will be considered in the f internal. So what happened if we summarize these things, right? So if we sum up these things, so Fi internal plus summation Fi external is equals to what? Summation dpi upon dt. Now see this. What will be the summation internal here? So the net summation, or you can say the net internal force will what? Wait, cancel out each other. So the pen is not working. So it will become what? 0. See this. How it happens? So let's suppose it will act F force, 2 will act a force F on this M1 in this direction. So it will act a force what? Minus F. So equal and opposite. Okay, we are considering the Newton's laws, Newtonian mechanics is here. So third law is equally valid here. So the internal forces balances out each other and the resultant will be what? 0. So it can be written as F external is equals to summation dpi upon dt. dpi upon dt. What is this? The net external force is equal to the summation of the rate of change of the all of the individual particles. What we can write it? So let's suppose if you closely look the this one, what we can say, F external, we can write F external. Let's treat the whole system of mass as a particle. So we can write the m total, total mass, into r vector double dot. We can write it, okay, F equals to mar, or you can, let's describe it at m total into isolation of center of mass. What I'm trying to give you, let's assume that if this force applied on a single particle, so what will happen? If the total mass is m total and this is the F external, it will produce a what? Isolation A center of mass. and it equals to what? That what we have written dp net, that was their summation upon dt, right? Or you can say the summation dpi upon dt. dpi upon dt summation can be written as summation mi ri double dot. Now let us compare these two things, right? So from here we can write r double dot is equals to summation mi ri over summation mi, because n troll is what? The summation of all of the masses. So this is what we can write, and this is what we call the isolation of center of mass. Okay, now if we can integrate it, what we will get? We can get r dot is equals to summation mi ri dot upon summation mi, that we have to find the velocity in the center of mass. This is what? The velocity. Now you can integrate it further and you can write r vector is equals to what? Summation mi ri upon summation mi, right? So we need to find out these two things: the position vector, you can check the right instantaneous position vector, and the velocity of the center of mass. Okay, so you have to go from these things. Do not consider that m1 is here and m2 is here and you are using the coordinate system. Do not use that method. Okay, you should use always this method. Also you should write, for a continuous system, r vector is equals to 1 by m. This is complete integration dm ri, where ri is what? Center of mass of small element. Okay, so you can give up to this much amount of what you can say explanation in this thing. Okay, so what you need to, what is the hidden in the question? You have to define what do you mean center of mass, what do you mean by system of particle, and you have to define the center of mass of system of a particle. You have to define the system of particle, then you should define what are the forces on the system particle, internal and external. Net internal force will become zero, right? Because they will follow third law of motion. And then after you can come to this one. You need not to show the integration part, right? You can simply write integrating with respect to time, we get this velocity of, and again integrating with it, we can get the instantaneous position vector. So this is about the introduction and the body part. What should we write in the conclusion part? So in conclusion part, you can write the application, or you can see the translational motion of the body is equivalent to translational motion of the center of mass. Translational motion. You can simply write this line. Okay, also you can write the toppling effect, right? If you're pushing something, either something from this direction, and it may can topple, but its toppling always depends upon the position of center of mass, right? Lower the center of mass, it will be difficult it to topple. Okay, above, higher the topple, above center of mass, it will easier to topple this. Okay, also you can use about the barycenter, right? Because most of the cases in our courses uh, we will study about the two bodies, right? So basically barycenter is something, if you consider sun here and earth here, what happens? Earth does not revolve around the sun. Actually both of them revolve around their center of mass, that is basically the barycenter. For two bodies which are under interaction with each other, right? They are under interaction with each other, or they themselves are balancing their forces and are in the stable form, so they move around the center of mass, and what we call that point, center of mass, in this case as the barycenter. Okay, so you can discuss about these things. Also, you can discuss about the some of the toys that are in the market using the center of mass thing. Okay, also you can say the stability of man, right? A man is standing here, he will fall or not fall depends upon the position of the center of mass. Okay, also some of the most example of the center of mass you can use in the car mechanics, right? They use the center of mass in every field. You can use the center of mass concept, but what suggest you to write I will suggest you write about the this one, barycenter and the translational motion, because we are central motion force, gravitational force, these are in our syllabus, so you should focus, you should write example that are within the syllabus. Okay, so this was for this question. Also, I suggest you to please do post your answer and review answers of others, right? This will motivate us to keep this program running. Okay, so do post your answer, also review answer of your fellow students, right? This will make your preparation even more better, right? Okay, thank you so much.